So continuous variables, there are 2-3 different ways of showing the continuous variable. One of this method we already discussed. Maybe just think about it. There is a way we represent the continuous variable that will also give us the distribution of the variable, and we will get to know what are the ranges of the variable from minimum value till the maximum value. We get to see everything. If there are any outliers also, we get to know that. Do you remember that plot that we have drawn for continuous variables that will give us whether there are any outliers or not? Yes, for continuous variable distributions, you can directly draw the box plot. There's a variable called balance. If you want to show the whole information about balance, the best plot that you can show is you can, from the minimum till the maximum, you can draw the box plot. What does box plot tell us? Can somebody tell me what do you infer from the box plot, or what does this particular box plot tell us about this balance variable? What does this particular box plot tell us? What do you get the information? Always make a comment on the outliers whenever you draw the box plot. Remember, you draw the box plot as a data scientist, you're going to make 1 or 2 comments on this graph, right? You're going to comment, looks like the box is really compressed here, which contains almost till here 75% of the data. That means there are some outliers in the data. Maybe you can also talk about the minimum value and the maximum value range. Like maximum, it is going almost till 100,000. Minimum is going even below 0, etc., etc. Negative balances are also there. But the important point that you are going to make is outlier. Yes. What about this one? Let us suppose you are creating a box plot for age variable. Again, you are going to say what is the minimum value, maybe around 20. What is the maximum value? Maybe beyond 90. There are slightly outliers here. There is a beautiful way of putting it. Box plot looks boring. There is a beautiful way of drawing the same one, which is known as violin plot. So basically here, instead of box, this violin will be shown. So this is the violin plot for our variable called balance. This particular box plot, this is the original box plot. Violin plot is a kind of variation of the box plot only. It also tries to show the same thing. And this is the violin plot for the age variable. You talk about the outliers only. Okay. Here also you talk about, you say that there are some values that are beyond this. If this violin plot is confusing, better to stick to our regular box plot, because here we get the minimum value, percentile values, median value, 75 percentile, and the maximum value. We'll also get some idea on the box plot. Okay. Maybe you can draw both the ones also, not at all a problem. You can show box plot as well as side by side you can show the violin plot. Okay. These are the methods to show the continuous variable distribution. There is one more thing that you can do. Continuous variables can also be shown by drawing the histograms. Histograms are something like distribution. Here we are largely focusing on the minimum percentile, which is a 0 percentile value, 25 percentile value. We are actually taking some important points from the distribution of the variable, 50 percentile, 75 percentile, and the 100th percentile value, and showing them in a graph. Whereas if you want to really show the complete distribution, that means from minimum to maximum, I don't want to simply focus on this, I want to show everything, then you can draw something called histograms. That means from minimum value till the maximum value. This is a histogram for age variable. You will roughly get the same one, like whatever is the values that you are seeing here. Near the 50 percentile, you have 40. Near the 25 percentile, you have 20, 30, and a minimum value 20. The same thing you will get, but you will see the original distribution. In fact, you can also add a continuous distribution kind of thing also by adding one more option, which is present in this one. We will see what is the option here. If we say KD equal to false, then that particular continuous smoothing curve will go away. Otherwise, by default, the smoothing curve will also show. Remember, this is not a different one. It is same histogram. They are trying to show this cumulative distribution or the count or the smoothing curve for the same frequency graph. At the end of the day, out of all these graphs, we are trying to convey what message are you trying to convey. Take a note of these 2 points. When you are giving any visualization about a continuous variable, always talk about the range. What do you mean by range? What is the minimum value? What is the maximum value? That is the first one that you want to make a comment. You also want to make a comment whether there are any presence of outliers. Though maximum value is around 100, I think 60 is the point, or 62 is the point where it starts saturating. Very few points are above 60. Most of the points are in this range. Like that, from here and the previous 2 plots, all of them are trying to tell us the same thing. This is the area that we have to focus. 75% of the data is below this. Maybe a lot of data is below this. So make a comment on the outliers, make a comment on the range. What I'm saying is, when you are doing this, when I'm driving it, it looks like everything is falling fine. First, we will do this exercise. Next, I will give you a challenge. Okay, I will ask you 1 or 2 questions. You may have to create these graphs and tell me the answer by looking at these graphs. Okay, first let us open the code file and try to draw these continuous variables visualizations. Okay, all of you open the code file. So first, get this data set. This is bank telemarketing data. This data set has been hosted on GitHub. You can directly download it from GitHub itself. This is the bank marketing data. Here is the head of the data. Here looks like there is only 1 column. The problem here is with the delimiter is not comma, it is semicolon. That's why everything is read into 1 column. So while reading it carefully, we have to correct it. Separator is not comma, though it says CSV file comma separator, but there is a special separator here. Separator is semicolon. When I correct it as semicolon, then you will get to see the original number of columns, which is 17. Now, when you see the head of the data, you will see all the columns properly laid out, and this is the information. Okay. Some variables are numerical, some variables are non-numerical, some variables are categorical. We'll try to go through all the variables, okay, one by one. As of now, let us focus on continuous variables. Balance is one of the variable, which is bank balance. So let us draw a box plot for the balance, which we have seen. There are outliers. Box plot for age variable. This is the one. In fact, these suggested outliers that you see, if you want to get rid of those suggested outliers, you can actually push that range. So internally they are using some kind of range, whisker range or something. We can modify that range and remove it, but you can ignore that as well. Always consider the maximum value as the actual box plot. Violin plots are exactly like box plots, a different way of representation, trying to show the distribution, like around 50, how many points are there, around the width they are trying to show, rather than a simple box. But
in the violin, what is how to find out the maximum and the minimum?
Maximum minimum is easy. Outliers will be difficult. Maximum is the max point, this one.
Okay.
So around this one and this one. But the difficult point would be like the way we have outliers here, okay, 75, 25 and all that, like the way we have in box plot. Those will be difficult in violin. Maybe along with violin, we may have to put describe also. Then looking at the describe values where you will get percentiles, and violin would might make sense. Yeah. Some places where there are sure short outliers like this balance one, violin also shows like this. Otherwise it may not be that easy. So just a box plot different version, but in terms of clarity, box plot is much more clear.
In the age violin,
Yeah.
how will explain this this chart?
So this chart is explained like this. So we have to say the maximum number of data points are around this one, wherever you see the largest width. The
Okay.
maximum number of data points, maybe let us suppose this is 35 or 36. Let us suppose that is 35. So you will say maximum number of points are around 35. There are some points around 40. There are some points like slowly by 60, most of the population is done. Okay.
Yes.
Beyond 60 also there are some people, but very less number of people are there. So this width tells you the count of people taking that particular value. If you come to this one 20, there are only very few people. As it increases, slowly it goes up, then you will get 30, 40 and all that. Okay.
So here also outlier is there, right?
Yeah, for sure. So
So
if we are seeing outliers in box plot, since this data is same data, you will make a conclusion that there are outliers here as well.
okay, sir.
Yeah, yeah.
Yeah.
So this width is the one that will tell us the count of people which are falling in that particular range. Maybe one comment we can make is the width is really high around this range. Maybe we will say maybe 30 to 40 is the range where a lot of customers or the lot of data points are around lying around. Clear? Or maybe your violin plot along with the histogram might complete the whole story. If you see the histogram of age, as we discussed, 30 to 40 is the people where there are a lot of count, isn't it? Which is also visible in the violin plot. So this along with histogram might give you the complete information, 30 to 40 range, or where exactly is this? Yeah, this is the one, 30 to 40, where a lot of clouds are there. And how do you create a histogram? You take the overall range from minimum value to maximum value, cut it into 10 bins and count how many customers or how many items are there in each of the bin, in each of the bucket, how many items are there. So basically there are some values that are starting from 18. Simply they might have cut it into 10 bins. So 0 to 20, very few numbers are there. 20 to 30 somewhat. 30 to 40 maximum number of range. You can see that, right? 30 to 40. 40 to 50 somewhat lesser. 50 to 60 lesser. 60 to 70, 70 to 80, 90 very less. The same thing is re-represented in this one. The same thing is again represented using percentiles and all that in this one. So all these three methods are for the same type of variable, which are continuous variables. Any questions on this? Will you be able to look at this graph and make a comment that what is the maximum value, what is the minimum value? Are there any outliers present in the data? Will you be able to look at these graphs?
20 to 30 to 40, there's a maximum.
Maximum frequency is there from 30 to 40,
Yes.
and then beyond 60, very few number of
Very
people
few
are
number.
there. Correct, yes. Yeah. But at the end of the day, you think from the reader point of view or the person who is looking at these graphs, the point that you want to convey, is it coming out of this graph or not? That we need to answer. If the point is not coming out, maybe we have to give more backup with some more data or more graphs, or we may have to add a table just beside it, or we may have to add maybe one or two lines we have to overlay just to make sure that the point that we are conveying is going out or appearing in this chart.
But sir, how will get to know the outliers in the histogram?
We have to look at the, like, if you want to know 100%, then you have to look at the box plot. Okay. Otherwise, here you will get a slight hint where the whole data will be in a certain range, and there will be some points that are very far away from the rest of the range. But decisive way, if you want to take it, you have to take it from the box plot.
Sir, that below one, 14.
Yeah. Yes.
So what does it mean, sir? It is.
Try to give it a first shot. I'll explain you this. There are 2-3 comments that you have to make. The first comment is, what are the minimum values? What are the maximum values? That is the first comment.
Yes.
So you will be making a comment on the minimum value, maximum value. Can somebody make the next comment? Are there any outliers in this data?
Yes, sir.
It's a very easy one, isn't it? We
Yes.
can very easily say there are outliers because looks like most of the data is concentrated somewhere here, not even shown in the graph. But let me guess that as 5,000 or something. Most of the data is below 5,000, but there are some data points that are going till almost 100,000. So I think there is a sure short case of outliers, isn't it?
Yes, sir.
Can you make that comment looking at this one? So basically this is that graph where you see that you will make a comment saying that most of the data is below this number. Maybe looking at the percentiles and all that, we will get to know maybe this is something like 5,000. 90% of the data is less than 5,000. Less than 10% of the data is going beyond 5,000. It is going as much as 100,000. Definitely this will contribute to outliers. Outliers are present, definitely present in this one. Maybe the previous one, I understand maybe it is not that easy here because the age variable is not showing that very reliant outliers, because age doesn't have that much far away outliers. Even if we look at the box plot, we can see that balance variable sure short outliers are there. Age is still, not very far away, or very extreme outliers are not present. That's why histogram also not showing a very decisive conclusive evidence. Whereas when it comes to your balance variable, this variable, definitely there are some outliers in this variable. Clear? Okay, let me give you some more examples. Now tell me, what about this one? Does it have any outliers? There is one variable. This variable name is previous. Okay, this previous takes from somewhere around 0 to 250. All of you need to tell me, previous, does it have outliers? Perfect. All of you are saying yes, yes. What
Yes.
about this one? P days. P days, minimum value is 0, maximum value is 800. P days, does it have outliers? Now this is age variable. Compared to this, does it have extreme outliers, or it does have outliers but not as extreme as this one?
Not extreme outliers.
Not extreme outliers, but it does have some portion of outliers, isn't it? Not extreme, not very extreme. That's right. Okay. So let us do these first. Then I'll give you one more example. There, I'll give you one more chance whether you can do it on your own or not. These are some of the examples that I have shown. What you can do is, if you want to automate this quickly, if you want to do it on, on every variable, what you can do is you will write this particular code where you get all the d types in integer or float. Basically, you will get all the numerical columns and then draw the histogram for them. This is known as list comprehension. You know how it works? You want to get all the numerical columns. Call for column in bank columns if it is in these two types. Let me explain how list comprehension works. This we may use multiple times. So in a list comprehension, you write result here, result, condition 1 space, condition 2 space, condition 3. You keep on writing the conditions. So here my result is I want to get the column name. Okay. What is the condition 1? For all columns, for column in the column names, that means df dot columns or anything, that is condition number 1 for me. So for every column I want to get the column name, but this will give me every column name. What is my condition number 2? Tell me. I want to get only numerical columns. That means space, I have to put the condition number 2 if column is in numerical format. So that is how I'm writing. Let me explain that once again. Result is the column name for column in columns. All of you, have you understood this first condition? Quickly confirm that to me. For column in bank data columns. This, what will this fetch me? If I write only this much of the code, can you guess what will be the result if I write only this much of the code? All the columns will be printed. Perfect. What is my second condition? If the
If it is
column, if the column D type is either numeric or float. Okay. If this is the second condition, if the column type is either this or this, then I want it to be printed. Apparently the numerical columns are age, balance, day, duration, campaign, p days, previous. For all of them, I want to draw the chart. So this will be the numerical columns If you print the numerical columns, you will get this result. Now here is the for loop that will run on all the columns. Look at this plot figure, that is a usual one. For column in numerical columns, that means column 1, column 2, like age, balance and all that. SNS is the package. Seaborn, the package name is Seaborn. This is a dedicated visualization package. Matplotlib is also a good package. Seaborn is also a good package. But I found a lot of people are using Seaborn. It has slightly advanced, very cool visualizations are there. So Matplotlib along with Seaborn is what I suggest to you. So Seaborn, distplot, basically for histogram drawing. Histogram is also known as distribution. Yeah. And then you take the column, whichever column you want to draw the histogram, and this is the title, column name histogram, and then plot dot show. So this will go through all the columns one by one, give you the result. All of you execute till here, then I'll introduce a new data set to you, then I'll ask you questions that are related to this numerical column, then we'll proceed further. Okay, go ahead.